Have you ever thought about a digital smoking gun? You know, a piece of evidence that seems to point directly at the culprit, but what if it's pointing at the wrong person entirely? In cyberspace, that happens all the time. Attackers are masters of disguise, using digital masks and false clues to operate from the shadows. And this is the attribution puzzle. It's a super high-stakes investigation where just one wrong move, one false accusation, could literally ignite an international crisis. So, to give you a sense of just how high the stakes really are, we're going to walk through a crisis scenario. It's basically a digital false alarm where some very misleading evidence pushes two entire nations right to the brink. Okay, picture this. Day 1, a massive cyber attack hits a country we'll call State B. The digital trail, it leads directly to computers inside a NATO country, State A. Day 2, bam, it happens again. By day 3, the headlines are just explosive. NATO member attacks State B. I mean, in just 72 hours, we've gone from zero to a full-blown international crisis. And it's all because those digital fingerprints seem absolutely undeniable. But are they? So now, State A is in the hot seat. I mean, how do you prove your innocence when all the evidence seems to be pointing right at you? Well, to figure that out, we have to start peeling back the layers of this attribution puzzle and really understand the dark art of figuring out who's actually behind the keyboard. This right here is the question. It's the central question in every single cyber investigation. But as we're about to see, the answer is almost never as simple as just, tracing an IP address. The digital trail isn't just a set of clues. It can be a masterfully woven web of deception. One of the sneakiest tools in an attacker's playbook is what's called a false flag operation. This is where an attacker intentionally plants misleading clues to frame somebody else. It's a really old idea, actually. The term comes from old-school naval warfare, where a pirate ship, for example, would fly a friendly flag to get close to its target, and then attack. In cyberspace, it's the exact same concept, just with malicious code instead of cannonballs. And then you've got the total opposite approach, a no-flag attack. This is where attackers try to be digital ghosts. They leave behind zero fingerprints, no identifying marks, nothing. Their goal is to make it completely impossible to know who was behind the attack, turning that attribution puzzle into a total mystery. So here's the really crucial takeaway from all this. Real, true attribution goes so much deeper than just technical breadcrumbs. It's not enough to find the computer that the attack came from. The real challenge, the whole game, is unmasking the person at the keyboard and ultimately the organization or even the nation they're working for. So how on earth do investigators connect the dots when the picture is so incredibly murky? Well, solving this puzzle takes collaboration. We're going to start by looking at one of the main solutions, technology and formal structured data sharing. But, it's not as simple as everyone just agreeing to share information. This survey from the Poneman Institute really highlights the hurdles. If you look at this chart, a staggering 84% of experts, that's the huge bar on the left, say the biggest problem is just getting threat intelligence to the right people quickly enough. By the time the info gets shared, it's often too old, or it's not accurate anymore, or it's just too complicated to even be useful. The solution, believe it or not, starts with a pretty simple idea: getting everyone to speak the same language. See, if different security teams are describing the same threat in totally different ways, it's basically impossible to connect the dots on a larger scale. So, that's why experts created these standardized frameworks to describe every single aspect of a cyber attack. And this right here illustrates one of the most important of those frameworks. It's called STIX. Now, I know it looks incredibly complex, but the idea behind it is so powerful. STIX basically provides a common structure to link all the different pieces of the puzzle: the threat actor, the campaign they're running, the specific TTPs, that stands for tactics, techniques, and procedures they use, and the incidents they cause. It turns what would be a chaotic mess of data into a coherent story that everyone can actually understand. Okay, so once you have that structured story, you need a way to share it. And that can happen through a few different models. And it really all depends on the level of trust between the groups. You might have a central hub-and-spoke model, or maybe a one-way source/subscriber feed, or for really trusted partners, a direct peer-to-peer exchange. But here's the thing, technology and formal agreements, they're only half the battle. Beyond all the code and the protocols, some of the most effective solutions are, well, a lot more human. And this is where we get into the really fascinating world of what are called operational security communities. Now, these are not formal programs with treaties and protocols. Nope. They are private, informal networks of security professionals, and they're built not on rules, but on relationships and good old-fashioned personal trust. Their entire philosophy can pretty much be boiled down to this one simple but incredibly powerful idea. If I trust you and you trust him, then I can also trust him. This is the principle of transitive trust, and it creates this amazing web of reliable contacts who can act super quickly when a crisis hits. This whole approach is sometimes called aggressive collaboration, and it's governed by a few really important unwritten rules. There's the chain of trust we just talked about. There's knowing who is in your sphere of trust. There's sharing information only on a need-to-know basis. And crucially, ensuring your contacts have a chain of action, meaning they have the ability to actually get things done. Okay, so now we're armed with this understanding of false flags, of data sharing, and these crucial human trust networks. Let's go back to our international crisis. It's time to solve this whodunit. So, how was the case finally cracked? Let's follow the evidence. Step 1. We had the public accusation, right? All based on those IP addresses. But then, step 2. A much deeper dive revealed the attack commands actually came from a server in a totally different country, State X, a classic proxy server used to hide the real origin. Step 3. Forensic experts found little clues inside the malware that pointed to a hacktivist group called H4KZ. And then the big twist. Step 4. Intelligence, probably shared through one of those trusted human networks, revealed that H4KZ operates out of State B, the supposed victim country itself. It was a classic false flag. The whole attack was deliberately routed through State A's computers just to make them look guilty, most likely to escalate an existing political conflict. Those digital fingerprints weren't evidence, they were a carefully crafted lie. So what's the ultimate lesson here? Well, it's that proper attribution is this incredibly complex blend of deep technical forensics, human intelligence and collaboration, both formal and informal. The consequences of getting it wrong are just enormous, and getting it right requires this sophisticated, multi-layered approach that combines the very best of technology and human trust. Which leaves us with a final, kind of provocative question. In a world that is just full of digital decoys, planted evidence, and false flags, the technical data can only ever take us so far. So ultimately, how do we decide who and what to trust?